4.1, and we talk about the kind of opposite of the differentiation. The opposite is going to be called, the first one was derivatives. Now we're going to have antiderivative. Okay, this is it. Antiderivatives. This is the way, I like to write it down, but we can put it all together. Antiderivatives. So as I talk about it, the procedure is going to be the other way around. The derivative of the function would be given to you. You want to recover the function. So we can check to see what is going to be the problem involved, and then we do it. So let's get some example first, the motivation. So the question that we are going to answer in this chapter altogether is going to be the following. So would like you to give us, find a function. Okay, find a function. Find a function, we call it f. Find the function f whose derivative, okay, whose derivative is given to you. Okay, derivative is given. Okay, so I'm going to give you a couple of cases to get to know the idea, and then we come back and we make it official. So the first part is this one. You see, f prime of x is equal to the 5x to the 4th. So this time you have the f prime. So we want to recover the f, okay, f of x. So what we are interested in for the solution, we are going to be interested in the function whose derivative is going to be 5x to the 4th. Any suggestion? Can you give us a function whose derivative is 5x to the 4th? Suggestion? Yes, let's see. We have one answer. Yes, I believe they're right. X to the 5th. So we note that this is it. If if the function is going to be x to the 5th, then the derivative of this function, sorry, the derivative of this function is simply 5x to the 4th. You see? But the question is going to be, is there any other function whose derivative is 5x to the 4th? You know that derivative of a constant term is 0. So if you have x to the 5th plus 1, the derivative again would be 5x to the 4th. If you have x to the 5th plus 10, the derivative would be the same. So the result is not going to be unique. You are going to have many, many solutions. So in general, you say, oh, note that I have much, much more. Note that if C is going to be a constant, it's going to be a number, a constant. Okay, it's going to be a constant number. Then you are going to have the same thing, you see, then f of x equal to the x to the 5th is going to be unchanged, but plus the constant c is also a solution. Is also a solution. Okay, so we are going to have many, many solutions. The solution is not going to be a unique one. Now, then what we are going to do is this f of x equal to the x to the 5th, sometimes we refer to it as a particular solution. But x to the 5th plus c, we refer to it as a general solution, okay? So f of x, because we are going to extend these ideas later on. So f of x equal to the x to the 5th is one solution, is a particular, okay, particular solution. And f of x equal to the x to the 5th plus c is the general solution. The general solution. Okay, so that's going to be the idea. This type of equation in future is going to be called differential equation. And when you find the f of x, we say, oh, you did solve the differential equation. But when you solve the differential equation, you may have a particular solution. You usually find this solution first. And then you say, oh, I can give you much more. X fifth plus radical 2 plus 1/2 plus 0.02. As long as this is going to be a constant, because derivative of a constant number is going to be 0. Okay, later on, we are going to give a name to this type of function. Okay, and this f of x equal to this x to the fifth is going to be called an antiderivative of 5x to the fourth. You see, the derivative of x to the fifth is 5x to the fourth, but we do it the other way around. Okay, but let's get more example. Any question? Just to get a good feeling of this problem that we're going to have, and then we put it together. So another type, for example, is going to be, suppose you have f prime of x equal to the cosine of x, and you want to find the function. Again, you think about it, you know that the cosine is the derivative of the sine. So one solution is going to be sine of x. So the solution is going to be, we say that, oh, if you let f of x, okay, f of x to be equal to the sine x, then you know that f prime of x is going to be equal to the cosine x. And so one solution is sine x. Again, you can give us a general solution. Okay, so note that if you want to be more precise, you can say that f of x in general is going to be sine x plus the constant c. So f of x equal to the sine x is one solution, but sine x plus c is going to be the general solution. Okay, is the general solution of this equation. Okay, the general solution. Okay, again, you know, previously the function was given to you, find the derivative of the function. Now we're doing the other way around. So in this case, we say that the sine x is antiderivative of the cosine x. Okay, so this is the procedure that we're going to have. Now we're going to give it a name with this type of idea that you find. Okay, so the expression that we're going to use is this function is going to be antiderivative of the given one. So the general definition is going to be this one. I quickly change it to the notation that it would be easier to handle, but we have to get the definition first. Now the definition is going to be this one. You are going to have two functions, you see, like the two functions that we got over here. So we're going to introduce a function. So if the first function, if f is going to be a continuous function, a continuous, okay, continuous function. This is going to be a continuous function, let's say on the domain, on its domain, on the domain D. That's the first function. Second one must be differentiable. And the second function, the big one, f is going to be a differentiable. Okay, if it's going to be differentiable, if it's going to be differentiable function, okay, differentiable function, such that this equation satisfies f prime of x is going to be equal to the f of x, like the one that we did over here. Okay, equal to the f of x, of course, for everything in the domain, for all x in the domain D. Okay, if this equation is given to you, you see, remember the idea was you find that f of x, that missing part. If this is going to be the case, as we talk about it, we are going to find the f of x. In that case, f of x is going to be called antiderivative. Then f of x, the function that you're going to find, is going to be called, okay, is called an antiderivative. Derivative. Antiderivative of the given function, okay, of f of x on the domain D. Okay, so if you have two functions that satisfy this condition, then we say that this f of x, the missing one, is going to be antiderivative, because when you differentiate it, that gives you derivative. You see, you're going back. This is given to, this is f prime. You go back, you call it f of x. This go back. So the going back is going to be f of x is going to be antiderivative of f of x, okay? So when the function is given to you, differentiated, that gives you the derivative of the function. If you have the derivative of a function and recover the function, you did the anti-differentiation. Now, quickly, as we did it over here, okay? As we did it over here, the result is not unique. If you add a constant c, okay, so again, note that, okay, note that again, if c is going to be, if c is a number, is going to be a constant, okay, then as we talk about it, if you add the c, you are going to get a new solutions. Okay, are you done? I go to the next page. If this is going to be the case as we created above, you see, if you have f of x plus c, if you differentiate it, derivative of f would be f prime of x, and derivative of a constant would be 0. So that gives you f prime of x. But remember, f prime of x was equal to the f of x. Okay, so this is it. This is equal to the f of x. So as we did it before, so this means, so f of x plus c is also an antiderivative. Okay, an antiderivative and antiderivative of the function. Okay, so it's not going to be unique. Now, you see, you can stay with this notation if you like, or previously for the derivative of the function, we use the notation of f prime. So what we would like to do is, would like to use a notation for this type of ideals that we are going to use over here. That notation is going to be called integral notation. So we change it to the integral notation that make it easier to handle and to operate. So what's going to be integral notation? Integral notation for this antiderivative. So that's going to be the one. Now this quantity is general solution. You see the quantity f of x plus c, that's antiderivative that we find, is going to be called, okay, the name, it's a new name, is called the indefinite integral. That's the notation. Indefinite integral. There's going to be a definite one in future. Okay, this quantity is going to be called indefinite integral of f of x and is denoted by notation. We call it integral notation. See, like the s, integral of f of x dx. Remember the differential that we talked about it the other day. So this notation is the notation of the integral, is like a big S. or a stretch S, and you are going to see later on why I say S. So, get used to it. Integral, integral, integral. This is the notation that we're going to use. So the quantity f of x plus c is going to be called indefinite integral. And is defined by, you see the one that we did. Remember, we're looking for we say that this is it. We say that integral of f of x dx, we write it as equal to f of x plus c, okay, if and only if simply f prime of x equal to the f of x for all x. So instead of calling this f of x plus c is going to be antiderivative, we write it down in this format. Okay, let's see what does it mean. This means opposite operation. You see, this is the one. You have f prime of x equal to the f of x. If you want to take the opposite of the f prime from the derivative point of view, so you would like to drop the derivative, it's going to be f of x plus c. So instead over here, we're just using the integral notation. So when this would be given to you, this means, you see, this means I would like to find a function. I would like to find a function whose derivative is f of x. That's the meaning of this quantity so far. Okay, antiderivative, not the derivative, you see. If you see this one, I would like to find a function whose derivative is f of x. If you claim that you find it, it's going to be f of x plus c, then you can check it. When you check it, okay, when you check it, that checking one give you, if you like, you differentiate both sides. If you differentiate this side, that gives you f prime of x. If you differentiate this side, now what is this? Remember, this is antiderivative of f of x. This is antiderivative. So if you find the derivative of antiderivative of f of x, that would be f of x. Okay, that's the meaning to remember it. Integral of f of x dx is antiderivative of f of x. So if you find the derivative of antiderivative of f of x, that take you back to the f of x. And the other side, derivative of f prime of x would just f prime of x, and the derivative of c is 0. That quickly give you a new machine. That machine is going to be very easy to handle, and that would be like the derivative of the function. So this machine is going to be called, in your book, they talk about it later, but we would like to talk about it now. You see, this machine is going to be called integral operator. Okay, integral operator. So the derivative is a differential operator. You see, previously for the first part of the course, this is what you did. A function was given to you, you see, a function was given to you. This is the function. You drop it into the derivative machine, means you differentiate it. So the result was denoted by f prime of x. That's a previous machine. Now this new one, you get the f of x. You drop it into what? You drop it into the integral machine. Integral machine. So that integral machine give you the integral of f of x dx. So this is derivative, okay? This is derivative operator. This is integral operator, okay? Or this is differentiation. This is antiderivative differentiation, if you like. Okay, so we are going to use this notation, which is much, much easier than the original one in order to talk about the antiderivative. Okay, so it's for the time being, this is the way you read it. Integral of f of x dx, I would like to find the antiderivative of f of x. Means I would like to find a function whose derivative is f of x. Let's give an example. The one that we did before, you see, look at this one. Example, the first one. Suppose you want to find the integral of 3x squared dx. We are going to give it the formula, but for the time being, we just want to just try to find it without any formula. Let's see what does it mean this. You want to find the antiderivative of 3x squared dx. Means you have to find a function whose derivative is 3x squared. So this is the meaning of this. You see the solution is integral of 3x squared dx. So can you find a function whose derivative is 3x squared? Any suggestion? A function whose derivative is 3x squared.
X cubed.
Excellent, x cubed. You see, but remember x cubed is one of them. But as soon as we find it, we add the constant c, we get many of those. Okay, as soon as you find one of, you see x cubed is one antiderivative, but we can add the constant c to get the general one. Anytime we use the notation of the integral, we are interested in the general one. You may say, oh, somebody say, if you want to check it, some of them are given to you. If we want to check, we say, oh, the reason is checking differentiate. If you differentiate this part, you see x cubed plus c. If you differentiate it, that give you what? That give you 3x squared, which is exactly this one. Or if you differentiate both sides, you see this is antiderivative. The derivative of antiderivative is just a function, 3x squared. And derivative of the other side, x cubed plus c is 3x squared. So both of them are going to be the same. This is the checking. There are some of them in your book, they ask you to check, but we don't ask you to check this. Any question? We are going to give a formula in a minute to find it, but we want to guess. Let's guess one trigonometric, and then we go to the formula, the other one. You want to find the integral of secant square of x. So what does it mean? This means I would like to find a function whose derivative is secant square. Can you guess? Give us a function whose derivative is secant square.
Tangent x.
Excellent, tangent x, that's it. So we say, oh, the solution is simply integral of secant square of x dx is tangent x. But tangent x is one solution. We add the constant c to give you all the solutions. Okay, so if somebody say try check it, we have some problems in your book. So the checking would be we find the derivative of, because this is antiderivative, but we find the derivative of this that give you secant square. Because it's going to be secant square plus 0. So we did find the function. This is your new machine that you're going to live with it through the end of the course. Okay, and most of the problem on the final would be related to the integration. And if you take calculus 2, 60% of calculus 2 are integrating. Okay, now this function was easy. So in the case of the derivative of the function, remember we did have some rules. If we did have the power rule, we have the product rule, sum, differences, etc. Even we did have a chain rule to be able to find the derivative of the function. It's going to be the same for this new operation. So what are going to be the formulas that you can use? Because these are easy. So if getting complicated, how are we going to find it? There are a number of easy formula. We are going to list them. And then you use those formulas to answer these questions. Okay, any question? So make sure you understand what we are doing. So we do it the opposite operation. So the derivative of the function are given. You want to go back. You see integration going to the past. Find the original function. Differentiation is future. Remember, derivatives rate of change is future. But the integration is going to the past, if you like. You see, going back, find a function whose derivative is secant squared. Now we are going to copy some property of the derivative to this new notation that will enable us to do the problem for the rest of this course. Okay, let's see. Of course, not all the theorems can be bring back here. There are some nice one, and we're just working on the nice one in this course. So this theorem is going to be very important for you. You are going to use this theorem in order to find the antiderivative for the rest of the course. Okay, theorem, this kind of computing theorem. So I'm going to call it properties. Okay, properties of indefinite. Okay, indefinite integrals. I'm not going to use the expression antiderivative anymore, okay? I just needed to motivate the definition. In some books, they stay with that F-prime format, but we are not going to do it. Okay, let's see. What type of properties can be extended? The first one. Remember, we did have this theorem that if you want to find the limit of the k times f of x, remember, k times f of x. If you have a number, you see 5 times a function, 7 times a function. So the limit was 5 times the limit, 5 times the derivative. Okay, so we always say that, oh, if you have a constant coefficient, just keep it. It's the same for the antiderivative. So that would be our first, okay, for the indefinite integral. So our first formula, which is going to be very useful, is this. If k is a number, any number, a number, then look at this one, integral of k times f of x dx, or antiderivative. You see, as you did it before, you can keep the k and work on the f of x. So it's going to be written as k times integral of f of x dx. Remember, derivative of a k times f of x is k times the derivative. So this is antiderivative. So in the operation that we do, we say that if you have a constant number, you can pull it out of the integral. You see it's going to be 5 f of x, you can keep the 5, then go inside and integrate it. Okay, only if it's a constant. So that's the first rule, and it's clear because it's true for the derivative, so it's going to be true for the antiderivative. That was the first rule. The second one, remember addition and subtraction? If you want to find the derivative of a sum of two functions, it's the derivative of the first one plus the second one. And it's also true for the difference. So it's the same for the integration. So the integral of f of x plus g of x dx, differential of x. See? For the limit, we distribute it. For the derivative, we distribute it. We get the derivative of the first one plus the derivative of the second one. So it's the same for the antiderivative. It's going to be integral of the first one plus integral of a second one. That will help us to integrate polynomials. That's it. And it's clear because it's true for the derivative. Okay, so integral of a sum of the integrals. And it's true for the, you see, if you get the difference, because this negative is like a -1. And as we talk about it over here, you can put it out. Okay, so integral of a multiple, you see a constant multiple, you bring the constant out. If it's going to be the sum of two functions, you break it, integral of the first one plus the second one. If it's going to be difference, the same thing. That's it. Any question? That takes us to most important one. This is the one. This is the one that takes care of all the problems in this course. Let's see what's going to be this one. Do you remember when you differentiate? What was the most important formula that you use when you differentiate? Do you remember?
Plus C.
No.
Oh.
The formula for differentiate. Remember the one formula that we use?
The product rule?
No, product rule is a good one, but we cannot use it here. Something else that you use to differentiate. What formula do you use to differentiate x to the fifth?
Power rule.
Excellent, power rule. You see, the power rule is the essential formula for the differentiation. So what is the power rule? You see, the derivative of x to the fifth is 5x to the fourth. And we bring the power down, or we multiply the power by the coefficient, and we decrease the power by 1 unit. Now we want to do it for the integral. So what's going to be the integral of x to the n dx? You see, you have to do the opposite operation. In the case of differentiation, we decrease the power. You see, we decrease the power by 1 unit. Say x to the n minus 1. The opposite operation would be plus. So this is going to be, the power is going to be x to the n plus 1. But in the case of differentiation, remember, we bring the power down. We multiply by the power. N x to the n minus 1. Opposite of the multiplication is division. Divided by n plus 1. Plus the constancy. This is the power rule for integration. We call it action of integration from now on. Action of integration is you move up the power. Up means 1 unit. X to the n plus 1, you divide by n plus 1. In the case of differentiation, you subtract, you see you decrease the power, and you multiply the power by the coefficient. In the case of the integration, opposite. Opposite of subtraction would be addition, and opposite of multiplication would be division. That's it. This is called the power rule. There is only one catch. The catch is, since you divide, you know that you cannot divide by 0. So you must be careful. This n can be any number except the negative 1. So this is true only if n is not equal to the negative. If it's going to be negative 1, we have a solution for it. It's a natural log. We talk about it in the next chapter in this book. Okay, so this is the one that we call it power rule. Okay, this is power rule for integration. For integration. You don't need anything else really to be able to take care of all these. So from now on, if you say action of integration is moving up the power 1 unit, x to the n plus 1, divide by n plus 1, plus the constant c to give us the general solution. Okay, any question? There is one more regarding the chain rule type. Remember the u form of the derivative of the chain rule, u to the n. We talk about that one later, and then we are done. So that would be after your quiz. So this would be number 4. You have to wait for it. Okay, otherwise we're done. We don't need anything else. There are some trigonometric one that we use, so I'm going to list them from time to time. We may use it. Okay, so the trigonometric one are going to be be just using the following. In calculus 2, we extend this idea, but not in this course. Okay, so the 5th one is going to be used. The one that I circled are important is going to be used. So the first one is sine integral of a sine x dx. You see, you want to find a function whose derivative is sine x. That function is, the derivative of a cosine is a negative sign. So you have to put the negative sign here to make it positive. You see, integral of a sine is negative cosine. Negative cosine, because the derivative of a cosine is a negative sign. Negative with a positive, that give it a sine x. Okay, let's make sure you know it. In the case of integral of a cosine, that's easy. You want to find a function whose derivative is cosine. Of course, that function is sine. Sine x plus c. You make a list of these formulas for your next, just coming, next test. That's a 6. Number 7. Number 7 is integral of a secant squared of x dx. You want to find the function whose derivative is secant squared. That function is tangent. Okay, and the other only thing that you can do at the moment is this one. Integral of a secant x tangent x. You want to find a function whose derivative is secant tan. You know that that function is secant plus c. You are not going to see them in this quiz, but we talk about it when we get to the next test. And these are going to be the trigonometric one. There are two famous ones that we cannot talk about it, but I made a list that you just know. You have to know it. This one of them is integral of a tangent x dx. We need a natural log, so you're not going to see it now. And the last one is integral of a secant x dx. These are all that you're going to see in this, in this course. So for the time being, for this quiz, you are not going to see any of these trigonometric one. When we go to the chain rule type, then we use trigonometric, but not now. So you are going to be concerned with power rule from now on. Okay, this is going to be the power rule. So if you have a single term, we can do it. If it's going to be addition, subtraction, we distribute it, be able to do the job. This is the collection of your formulas. Any question? Now I'm going to give examples to see how I'm going to operate. So I give you some, I break it into parts, the warm up to get all the possibilities. But it's usually two types of function that we would like you to integrate at this level. And we give you both of them on this quiz, next test, and on the final. Okay, are you ready? So this is, make sure you know the formula, the power rule. So let's see what is going to be the type of examples that you can have for the antiderivative, or I'm going to call it integral, indefinite integral, okay? So this is going to be your job. The warm-up first, I give you all the possibilities. You have some in your book, but the way we are going to question you, talk about it later. So find each integral. Find each indefinite integral. It doesn't matter, indefinite integral or integral for the time being are going to be the same. Find the indefinite integral. Give all the possibilities. The first one. The first one, straightforward. Integral of x to the fifth dx. You see? Is the power of x, you just use the power rule. Power rule, solution, integral of x to the fifth dx is equal to the power rule, action of integration. You add 1 to the power. This is the first one, I write it down. X to the 5 plus 1. You divide it exactly by that, 5 plus 1. 5 plus 1 is 6, x to the 6 over 6. But remember the constancy, the constancy. You always should give us the constancy, even you have to write this here. Okay, so we call it action of integration, action of integration. Move the power up, x to the 5th would be x to the 6 over 6 plus c. In the case of the differentiation, you multiply by the coefficients, okay, multiply by the powers. In the case of the integration, you divide and you're done. Any question? That's case 1. Case 2. Case 2, negative power. X to the negative 4 dx. It doesn't matter. We can do all sorts of powers. Okay, solution. Action if integration. X to the negative 4 dx equal to, move up, x to the negative 4 plus 1. Negative 4 plus 1 would be negative 3. Divide by negative 3 plus the constancy. Okay, move up the power, x to the negative 4 plus 1. Negative 3 over negative 3. We are not going to accept the negative here and the negative as a power. You have to simplify it. So this is going to be a sign of the fraction. I just do it in 2 steps so that you can see it. It's going to be x to the negative 3 over 3 plus c. And you know that you bring this power down. So make it to the negative 1 over 3x cubed plus c. This is the final answer. Okay, no negative power here and the negative sign here. In the case of differentiation, we let you write this one as is, but not in the case of integrations. Any question? So this is how you handle the negative power. Next, I give you all the possibilities for the powers. Next one is this one, x to the 2/3 dx, rational power, doesn't matter. Okay, action of integrations. This is it, solution. Integral of x to the 2/3 dx is equal to the x to the 2/3 plus 1. 2/3 plus 1 is like 2 plus 3 is 5. 5/3 over the 5/3 plus the constant c. You see, 2/3 plus 1. You write it down as a 2/3 plus 3 over 3. So that would be 2 and 3, 5/3. Okay, so, if this denominator is going to be 3, 3 over 3, 5, 5 over 5. So the quickest way to do it is to find the top, 2 plus 3. At the top and the bottom, 2 plus 3 would be 5. Okay, 5/3 over the 5/3. Okay, any question? That is going to be, no. C is the constant, remember? C is just, no. Dx is the differential of the x that you will see in future. That will tell us we integrate respect to the x. No. Remember, we talk about it. If you find one solution, derivative of a c is 0. So if you find only one solution, that's it. But you can add the c because you may have, x to the 5th plus 1 plus 2 plus 3. No, c is part of our definition that we are going to have. You're not done, and you have to use the reciprocal. Okay, that give you 3/5. Okay, 3/5 x to the 5/3 plus c. You see, because if you just differentiate this one, that give you x to the 2/3. But you know that if you add the constant c plus 1 plus 2 plus 3 plus 5, the derivative would be the same. So that's why we add the c to find all the solutions. No, c is part of our solution, nothing to do with the dx. Any question? So this is, so we can handle the rational power. How about the negative rational number? So x to the negative quarter dx, same thing, solution. So integral of x to the negative quarter dx equal to x to the, now negative quarter plus 1. Again, this is the way you think about it. Is a negative 1 plus 4. Put the negative on the top. Negative 1 plus 4. Negative 1 plus 4 would be 3. So that gives it 3/4 over 3/4 plus the constant c, because you have to give us all the solution, general solution when you add the c. Okay, so use the reciprocal of the 3/4, which is 4/3. 4/3 x to the 3/4 plus the constant c, and you're done. Okay, I just show you. You see, this is negative quarter plus 1. It's going to be negative quarter. You replace the 1 by 4 over 4 this time. You see 4 minus 1, 3/4. So the quickest way to do it, it's a negative 1 plus 4. Negative 1 plus 4, negative 1 plus 4 would be 3, positive 3. Any question? So we can handle the positive, the rational powers are going to be your challenge. Okay, get used to them because they are going to be quite a lot. Any question? So what's going to be the other possibility? The other possibility is going to be this one. That was a number 4. Okay, let's check number 5. Number 5, how about a radical function? Radical function, okay? So the integral of the 4th root of the x cubed dx. You see the radical function? Remember, we can do only the power rules. What are we going to do first for this one? For the radicals? Remember what you did?
Rewrite it.
That's it, rewrite it. Yes, very good. Like differentiation. We don't like radicals. We don't like radicals. We don't like fractions. Rational function in calculus. Okay, so you have to rewrite it. Remember, the way we write this, just remind you the formula that we use. There was the n root of x to the m is going to be x to the m over n. Okay, and the radical x is of course x to the half. So you have to rewrite it. So this is going to be the solution. The solution is going to be rewriting first, so it's going to be integral 4 x to the third dx. So that would be 3/4 of dx. Remember, as long as you haven't done the integral, you just keep the notation. Now we can do it. It's going to be x to the add 3/4 plus 1, 3 plus 4, 7, 7/4 over 7/4 plus the constant c for the general solution. Now 7/4, use the reciprocal. So that give you 4, 7, x to the 7, 4 plus c. Done. You don't have to write down in the radical form. Some people they do, but we don't accept any negative power. But the rational power are fine and nice. Okay, so this is the way we are going to handle the radicals. Okay, we rewrite it to get the radical expression question. What's going to be the next one? The next one is this. Number 6. Number 6 is, let's say 1 over x to the 8 dx. Remember, we have only the power rules. Any suggestion for this one?
Rewrite as a negative power in the numerator.
That's it. Very good. Yes, we move it up. Remember, we did it before. So we remind ourselves that this is it. If we have 1 over x to the n, we move it up into the x to the negative n. Okay, so the solution is going to be, we have 1 over x to the 8 dx, rewrite at x to the negative 8 dx. Now, action of integration. You add 1 unit to the top is a negative 8 plus 1 would be negative 7. So x to the negative 7 divided by negative 7 plus c. Remember, no negative signs. This is a sign of the fraction. So this is going to be negative. You bring the top down. 1 over 7 x to the 7 plus the constant c. This is how you are going to present the final. Okay, present the final answer. Any question? So these are 6 possibilities that we can have. We have 2 more. To check it, of course, we put them together. That would be our problem. But we just want to make sure you know it, this part. Okay, so let's have, what's the next? This next one is the kind of most general one that you can have with these single terms. So what is number 7? Is it number 7? Number 7 is this one, integral of 1 over cube root of x squared dx. That's the one that some people they miss it. Any suggestion for this one? What are we going to do first?
Rewrite the radical.
That's it. Very good. We rewrite the radical. Okay, let's do it into a step so we can see it. So the solution is going to be, so it's a 1 over cube root of x squared dx. We rewrite the radical. It's going to be 1 over x to the 2/3 dx. Okay, next, what are we going to do next?
Make it a negative power.
Excellent. Yes, we move it up. X to the negative 2/3. Okay, just make sure you know. Some people do it right away, but make sure you have the negative here. Very good. Now it's power rule. So it's going to be x to the add negative 2/3 plus 1 would be negative 2 plus 3, which is 1/3. Okay, over the 1/3 plus the constant c. You use the reciprocal of the 1/3, which is going to be 3. So it's going to be 3x to the 1/3 plus the constant c as the final answer. Okay, so this is all the possibilities that we can have with this expression that we have. Any question? This is clear, but we just would like to make a note of this. You see, if you have integral of 5 times dx, any suggestion for this one? You would like to find a function whose derivative is 5. What is that function?
0.
No, not 0. No. What was the other one?
5x.
5x. You see, you can think about there are different ways to think about this one. You see, you can think about the 5. One thing to do is you can move it up. Moving out is a constant. It's going to be 5 integral of a dx. Integral of a dx, you see there is a 1 here. Or just integral of a dx is differential of the x. So if you go back, that give you x. Or you can think about the 1 here. You want to find a function whose derivative is 1. That function is x. So it's going to be 5x. 5x plus 1. I'm sorry, 5x plus c. Okay, different way to think about it. The other way to think about it is going to be this one. You see, it's a 5 dx. You can think about it as a 5 times x to the 0 dx. You know that x to the 0 is 1. So now you add the power. Add the power, this is 0, so we change it to the x plus c. So it's going to be the constant. You see, integral of a 5 dx, it's a 5x, 7x, etc. Okay, so any question? Now we are done with the preliminaries. Now we would like to get the real things. The real things is going to be a couple of these would be put together, and then you'll be asked a question to do it. So you have to break it into parts. How we're going to do it, you see the property that we have here. We can break it into the sum and the differences. When you break it to the sum and differences would be one of those 6, 7 types that I talk about it. And then you can do it. If there's going to be, of course, any radical, you switch it, any fraction, you switch it to get the final answer. Okay, so this is how we're going to question you. One problem, 2 parts of this integral for this quiz, next test, and the final. Okay, so this is our real example. Would like you to find. Okay, find each integral or indefinite integral. The type 1 is very popular that we use from time to time. So this is it, just the warm up, this one. Okay, suppose you have something like, let's say 6x squared plus 7x minus 10 dx, a polynomial. I show you the operation as it's happened, but we usually use the shortcut to do it. If you want to think about it as a theorem that we talk about it, you have to break it first. So the solution using a step-by-step theorems is going to be this one. You say it's a 6x squared, 7x minus 10 dx. We break it into integral of the first one, the second one, and the third one. So it's going to be integral of a 6x squared dx, the first one, plus integral of 7x dx, the second one, minus integral of a 10 dx, 10 dx. Then we can pull out these coefficients because we have a theorem, 6x squared dx. 7 x dx. And the last one minus 10 integral of a dx. Now use the power rule. This is 6. Power rule, move it up. X cubed over 3. That's the first one. Plus 7. Move up the power. This x to the first power would be x to the second power over 2. Minus 10 integral of a dx is x. Remember? Because there is a 1 here. But make sure you add the constant c at the end. You simplify it if you can. These two would be simplified. That give you, okay, that give you 2x cubed. Okay, and this is going to be plus 7/2 of x squared and minus 10x plus the constant c, and then you're done. Okay, so that would be the final answer, if you like. Any question? This is how we break it into parts, really. But in practice, we do it right away because we know the theorem. Okay, so this is the way we would like you to do it, short form, if you like. And we use this one because we already talked about this. You see, when you want to integrate this integral, so that's a given one, 6x squared, 7x minus 10. First thing to do, you have a look. If there is any radical, you rewrite it. If this x is going to be down the denominator, you move it up. Because we can do only the powers of the x, remember. So everything is nice here. So we integrate it one by one and we move forward. See, this is going to be equal to 6 is a coefficient. We keep it. For the x squared, we apply the power rule. Move up the power. X cubed over 3. Done with the first one. Next, 7 is the coefficient. You keep it. Power rule. For x, the power is 1. So you move it up, x squared over 2. Done. Integral of negative 10 would be negative 10x. You see, we take this one because you want to find the derivative of, we want the function whose derivative is 10. It's a 10x and the constant c. That's it. You simplify it if you can, and then you have the final answer. So in this case, this is going to be 2x cubed. Okay, it's a 7/2. It's the way I write it down. Some people write 7x squared over 2, which is the same thing. 7/2 of x squared. Okay, minus 10x plus c, and then we done. Okay, we like this type of operation. Don't try to. I've seen some people, they even break it like doing it by a machine. They write a 1 page, for this. You're going to have quite a lot of this. Okay, it's short form because it's a theorem. So the theorem will tell you that you can break it into parts, and you can integrate each part separately. So that's it. So there's no radical, no quotient, so we can operate right away. Okay, this is going to be a kind of 6. You keep the 6, x cubed over 3, 7x squared over 2, integral over 10, 10x, and then you're done. Okay, so I give you another one in the short form to see how we operate it. Any question? It's a polynomial. It's very popular. We have many, many cases. But we are going to see it, one of those cases that you need. So to make it, make sure that we are know how to handle it. Suppose you be given this one, you see 5x to the 4 minus 6x cubed plus 9x squared minus 8x plus 12 and the dx. Just give you a couple of minutes to see if you can do it yourself, or the final answer just using those short form. There's no radical, no quotient. You just integrate and just go on. And if you have a solution, let us know. And I'm going to do it.
I have a solution.
Yes, read it.
I have x to the 5th minus 3/2 x to the 4th plus 3x cubed minus 4x squared plus 12x plus c.
Excellent. Yes, you are right. Very good. Yes, this is it. Solution. You see, there is a no change, nothing to change. If you don't like to repeat it, you can restart with the I. We accept it. Let's just do it. So that's it. We keep the 5 as a number, move up the power, x to the 5th over 5. 6 is a coefficient. You move the power, x to the 4th over 4. 9 is a coefficient. You move the power, x cubed over 3. Minus 8 is a coefficient. Move the power, x squared over 2. Integral of 12, 12x. Because this is 12x to the 0. It's going to be 12x. Make sure you know the constancy. That's it. Simplify. So the answer would be x to the 5th. You simplify. You have to simplify those coefficients, the fraction one. So that give it 3/2. Again, 3/2 x to the 4th is the way I write it down. We write 3x to the 4th over 2, which is going to be the same thing. Okay, you simplify these two, that give you 3x cubed. And you simplify these two, that give you minus 4x squared plus 12x. Okay, 12x plus c. So that give you the final answer. The polynomial types is coming for the application that we're going to have. The more serious one is, the next two examples. Okay, I'll give you a break. Then we come back and we have 3 serious examples that we have to check it. Okay, we check it and there is a kind of application. Then you can finish this section. Again, it's very important one. This is your job from now on and through the 60% of the calculus. Okay, so it's a 9/11. So let's have something like 10, 12 minutes and we come back. Come back at 9:25. And then we give you those 3 famous ones that's going to be on the quiz and your next test. Okay, see you then. Okay, so we are going to continue. Give you those more serious problem. Okay, that's a type 1, a polynomials, but mostly, you'll be given something with a rational expression and the radical at this level, and these are going to be the two problems that we usually will be given to you. Okay, so we continue, and that would be example number. Okay, number 3. It's a little bit of a challenging one. Is this one? Pay attention. Okay, so it's going to be integral of. Usually give you a couple of radicals, fractions. We say 4 radical x plus 3 over x cubed. Okay, x cubed minus 10 dx. Remember, we can only do the power rule. We don't have anything else. So as you can see in this problem, we have a radical here, radical x, so we have to take care of it. We rewrite it as x to the 1/2. You have the x cubed on the denominator. You're going to move it up, make it to the 3x to the negative 3, then you integrate it. Okay, so you need to be, okay, to rewrite it if you like. So the solution is going to be, your integral is going to be this one, 4x to the 1/2 plus, you move it up, 3x to the negative 3 minus 10. Okay, remember this is just rewriting it, you're not done. Now for each term, as we did it before, we keep the coefficient and we use the power rule for the rest. So the first one going to be 4. So action of integration, x to the 1/2 plus 1. It's like 1 plus 2, which is going to be, okay, 1 plus 2, which is going to be 3 halves, but you divide it by the 3 halves. That's the first one. Okay, so that would be the first one. Now the second one, the coefficient is 3. So the power x to the negative 3, you move up 1 unit, x to the negative 3 plus 1 would be x to the negative 2. Okay, x to the negative 2 divided by negative 2. And integral of a 10 is 10x minus 10x plus the constant c. Okay, for the numbers, we talk about it. You can think about it as a 10x to the 0. That would take you, give you 10x. But you're not done. You have to simplify it. These numbers use the reciprocal. You multiply by the 4. It's going to be 4 times. Okay, you flip it, the 3/2 into the 2/3. Okay, 2/3, then x to the 3/2. And over here, no negative. This is going to be negative sign of the fraction. So it's going to be -2, negative. You get a fraction bar. You put the 3 on the top. You bring the x to the negative 2 down. It's going to be 2x squared. Okay. So this is going to be negative, positive, negative sign of the fraction. 2 stay down the denominator. X to the negative 2, you bring it down. And minus 10x plus the constancy. Okay, then you try to see if you can simplify. You cannot simplify these two together. You have to multiply it. 4 times 2 would be 8. So 8/3 of x to the 3/2 minus 3 over 2x squared minus 10x plus c. This would be the final answer. Okay, so you got to be patient, be careful about this, extra algebra. This algebraic operation that you just rewriting it and just getting the result, and at the end, of course, you simplify it. You see these numbers over here. We bring it up, use multiply by the reciprocal, and then we be able to get the final answer. Okay, any question? So be careful about these radical expressions. There's another one. This is also, you need to know it. You get a couple of them in your book, and it's always around, one of those category of this section. So this is it, integral of. You see on the top would be x to the 4th, x to the 4th plus 3x plus 1 divided by x cubed dx. Very popular integral. Okay, then the denominator would be, even can be radical x, fifth root of x, all of them are going to be the same thing. Now, the way we think about it, it's a fraction, we talk about it, we move the x cubed to the top. Okay, you move the x to the top, but you got to be careful when you move it to the top, it's going to be x to the -3. Then you have to multiply by everything, okay, by everything on the top. Some people, they make a mistake. When they move it up, they just multiply by x to the 4th, which is not correct. Just make sure you get it. Okay, so we have to rewrite it. This is the way we're going to rewrite it. Move this one up, x to the -3. Open up the parentheses to make sure that you are going to multiply by all the terms on the top. You see, this is going to be the one. Now you have to distribute it. You multiply it inside, and you know that when you multiplying, okay, we multiplying, we add the exponents together. So this is going to be equal to x to the, it's a -3 plus 4 exponent, so that gives a +1, plus 3x to the, it's a -3 plus 1, that gives me -2. Okay, -2, and the last one would be x to the -3. Make sure you get these, these powers all right. Any question? So I move it up. The difficulty, as I told you, some people, they don't use parentheses. They multiply, they bring it up, and then they just multiply these two together, which is not correct. You have to multiply by everything inside one by one. So when we multiply, we add the powers, -3 plus 1, +1, -3 plus 1, -2, and the other one. Now we integrate it. That's it, the power rule. X move up, x squared over 2. The coefficient 3, we keep it. X move up the power, and -2 plus 1 would be -1 over the -1. And this is going to be x to the -3 plus 1 would be -2 over -2, plus the constant c, of course. Now take care of those negative powers and the negative sign. The first one, you cannot simplify, the x squared over 2. And this is going to be positive, negative would be negative. Get a fraction. You put the 3 on the top of the fraction. You bring the x to the -1 down. X. Okay, this is positive, negative would be negative. You get a fraction. You move this one down. 1 over 2x squared plus the constant c. This would be the final answer. Any question? Now, this is one method. I've seen some people, even in your book, this is the way they suggest. I prefer this one, of course. But I just remind you, you see the method 2 is the same method, but the algebra is a little bit different. The way they simplify it, they break this one into the partial fractions, if you like. This is the way they write it down. So this is the original one, x to the 4 plus 3x plus 1 over x cubed dx. We can write it on as the sum of the like fractions, we call it. So they write this one as x to the 4th over x cubed. They divide it. Plus 3x over x cubed and plus 1 over x cubed. Okay? They break it. Then they simplify it. X to the 4th and x cubed would be x. 1x would cancel out, so that gives a plus 3x squared. And over here would be just 1 over x cubed. You see? This is the way they know they got rid of it. But you know that you have to change it into the negative power. So this is going to be x. You move this one up, that gives it 3x to the -2, and you get x to the -3 dx. And that's exactly what I got over here, you see? And then you can continue, okay? These are going to be all the same. So you continue the similar one, and you arrive at the same solution, x squared over 2, okay, minus 3 over x, minus 1 over x squared plus c. Okay, so 2 options, but I prefer this one because as soon as I multiply, I get the negative sign already. So over here, you simplify it, then you have to change it to the negative one. But, you know, it's very popular problem. So you will see it from time to time. Just pick a method that you feel comfortable, okay, that you are going to be able, you know, to give us the final answer, and we will be happy. Any question? Now, these are all the possibilities that, you know, that you can have. Now, there is one more problem about these problems that you're going to have. We are going to use this in science, in applications, and you will see it later on. But when we do this type of problems, you see this constancy that you have here. So this constancy, as we talk about it, is the fact that you see if you get one solution, if you want to graph this solution that we're going to have, so these are going to be the case. So that constancy, you have done this type of idea in college algebra, that you see if this is going to be your function, for example, if this is going to be a function y equal to the x squared, if you add one in college algebra, we say shift it up. So if you shift it up, so this would be y equal to the x squared plus 1. And then you can do it, you know, more and more. So you can have a family of function, if you like. So this constant c means y equal to the x squared plus c, means you are not going to have one solution, you are going to have many, many solutions. So we say that the solution of these indefinite integral or antiderivative are family of solutions. You see, these are a family of solutions. It's not one solution. But when you are going to be in science, you are going to be interested in one solution only. So if you are going to be interested in only one of these solutions, you have to give us a hint. You have to give us an address. So the address would be, you have to give us a condition that enable us to find the C here. So you have to tell us that, for example, you have to give us 1 point of this graph, if you like. So you have to tell us that I would like to find a solution that passes through these points. For example, the point is going to be 1 and 3. Point 1 and 3 means f of 1 is equal to 3. So you are going to give us 1 point on the graph of the function that we're going to be interested in. So we can use that 1 point to find this constant c. Okay, so that would be enable us to find the so-called the particular solutions. It's going to be used in the terms of format that I talked about the other day, differential form or the differential equation. Remember, the derivative of the function is just rate of change. So they may give you the rate of change as f prime, and they ask you to recover the function, but they may give you an extra condition. So this is going to be the second problem. Quickly, a kind of application of this type of ideas. Okay, so this is how they are going to express the problem for you. That version was the version of the integral, but this is the second problem that we have. And you are going to see it on your quiz. So they express the problem again, because we haven't talked about differential equation. So they give you the problem in this form. Find the function. Find the function y equal to the f of x, one function, y equal to the f of x, satisfying the following condition. Satisfying the following conditions. I'm going to give you two conditions. You see, this is it. I'm going to give you two examples. So I do the first one is this function, and they give you f prime of x, which is the rate of change, okay? 9x squared and 9x squared minus 4x plus 5. And the initial condition, we call it f of 0 equal to the 4. See, that's the point that I talk about it. Point is 0, 4. And that would be a point on the graph of the function. So you can think about this one as a rate of change. So you have done some experimental work and you get the rate of change and you would like to compare your function. Or if this is going to be your position when you're driving. So if you give us the f prime, you know that it's going to be velocity. So if you give us the velocity function when you drive, we be able to find your location if you like. So your location or your position function would be f of x. So it depends in which context are you going to use these type of ideas. But basically, since you want to recover f of x, you have to integrate. Okay, going back, remember, antiderivative. So to do the solution is going to be, so we use the definition of antiderivative. We go back, we say f of x is going to be equal to the integral of 9x squared minus 4x plus 5 dx. So we change it to the notation of the integral. Okay, we take the antiderivative of f prime would be just f, and the antiderivative of this one is just the integral that you have to find. Now, find it. There's no radical, no quotient, so we can go ahead and just do the job. So this is it. The integral is going to be what? It's going to be equal to the, we keep the 9. Integral of x squared would be x cubed over 3 minus 4. Move up the power of the x, that gives you x squared over 2. And integral of a 5 is 5x, but don't forget the constant c. Okay, simplify it if you can. So it's going to be f of x equal to, that would be 3x cubed. And that gives you minus 2x squared plus 5x plus c. You see, this is going to be, we call it the general solution, because you have the constant c, the general solution. Okay, you have a family of those curves. These are the ones that we talk about, you see. We call it a family of curves. But you have the initial condition, they give you a condition. F of 0 equal to 4 means this is the one that you are going to use. You find a special c for this point. And then that would be so-called the particular solution, okay? So we have the initial condition, we say, oh, but I have f of 0 equal to the 4. You see, in order to find the c, you need an equation. This is the equation. So go back, replace the x by c 0. Then your function would be equal to 4. If replaced by 0, that gives you 0, 0, 0. So that gives you 0 plus c, which is equal to 4. So c would be 4 for this problem. Okay, so you put the 0 on both sides of the equation. F of 0 is equal to 4. And if you put the 0 here, that gives you just c. So we go back and substitute for the c. So f of x equal to the 3x cubed minus 2x squared plus 5x, c. C is equal to 4. And then you're done. Okay, so the difference is the c, because you have a so-called a particular solution, one solution. If they give you initial condition, they give you one solution. But otherwise, you can provide all the solution that you're going to have. Okay, it's used in science. These integrals that we do in this course are easy. When you are in science, there are some functions that would be very difficult or sometimes impossible to find the integral as we do it over here. But if you have initial condition, then we can use calculator. Because when you use initial condition, we are interested in one solution. So we can find it quickly rather than lots of solutions. So there are some of them. There are some names, that we are not going to use for the time being in this course. Okay, any question? So it's the same operation, do the job at the end, go and find the c. This is a polynomial type. I give you some fractional type. So that's number 2. Again, one question, 2 parts for your quiz. So what is f prime of x is equal to, we have something like x squared, something like your book, 3x cubed. And the initial condition is that f of 1 is equal to the -2. Okay, again, the derivative of the function is satisfying this condition. You have the initial condition. So in order to find the f of x, to integrate it, and when you're done, you have a constant c. Then you can use this condition to find your constant c, okay? So this is going to be the solution. Say we integrate, so f of x would be integral of x squared plus 3 over x cubed dx. You find this integral, of course, there is x cubed here, you have to move it up. So it's going to be integral of x squared plus 3 x to the -3 and the dx. Okay, integrate it. Use the power rule, x squared would be x, so it's going to be x cubed over 3 plus 3 is a number, x to the, that's a -3 plus 1 would be -2 over -2, but don't forget the constant c. Simplify to get the f of x, so f of x so far is going to be x cubed over 3. You have to check, it's going to be minus, this is sign of the fraction. You put the 3 on the top, 2x squared on the bottom, plus the constant c. This is going to be your general solution. Any question? But we are not done because initial conditions given to you. See, f of 1 equal to -2. So you have to apply this initial condition. So, oh, I have f of 1 equal to the -2. So this means goes to the equation, replace the x by 1, and let this one to be equal to the -2. So if you put the 1, so that give 1/3. Okay, minus 3/2 plus the constant c, but it's going to be equal to the -2. Okay, now we have to solve for c. And you do a little bit of simplification. We'll just move everything to the other side and then find the common denominator. So c is going to be equal to, I have a -2 minus 1/3 plus 3/2. So the common denominator would be 6. Okay, 6 times -2 would be -12. 6 divided by 3, that give you 2, that give you -2. And 6 divided by 2 would be 3. 3 times 3 would be 9. So that give -14, and the 9 is going to be -5/6. -5/6. So C for this problem would be -5/6. So you have to substitute to get the express the final answer. So f of x is going to be equal to the x cubed over 3 minus 3 over 2x squared and the c, which is 5/6. So that gives you the kind of final answer that we're going to have. Okay, any question? So you see the kind of application of these ideas quickly, they'll be able to do it. Just there were a couple of problems in your book. If I can check one of them for you. It's in 4.1. It's the same thing, but sometimes the notation I remember is different. I just want to make sure that you have no difficulty taking these. Okay. So this is in your book. And that's the idea of this, that I talk about it. You see, get different C's, and these are the particular solutions and the case that we talk about it. Okay, our example is going to be much more involved than the one in your book. So in the format that they be given in practice. And I just want to give you one of them, but because we are going to use this type of idea in calculus 3 for the moving object. You see f prime is the velocity. If you differentiate it again, f double prime would be, okay, acceleration. Sometimes that acceleration part would be given to you and they ask to recover the function. Okay, so instead of this is what I am talking about. You see this group of problems in your book. They call it solve the differential equation. It's the same thing. This type of equation that you solve, they are a kind of differential equation one. These are very easy problem, in your book. So it's the same thing. The one that I gave you was very much more involved when you put them together. So I just try one of these f double prime for you. I'm not going to give you f double prime, okay? But just make sure you understand it. But otherwise, this is all we done. Okay, just pick some of these numbers. So that's going to be 4.1. Okay, so in case in future you take calculus 3, or if you are going to be in physics, so these are going to be just f prime, which is going to be the velocity. So I give you one with the f double prime to see how we're going to handle those, but we are not going to question you on that. Okay, so this is going to be number 1, 2, and number 3. Okay, in number 3, you may begin f double prime, no big deal. Okay, this is acceleration. An object is moving, the acceleration may be given to you, and they ask for the position of the object. Okay, so let's have f double prime of x, which is going to be, okay, how about 6x squared? Okay, 6x squared and plus, okay, plus 3x plus 1. In physics, this is going to be, they call it t because that would be for the acceleration against the time. Then they give you, you see, anytime you integrate, there is going to be a constant c. Since this is f double prime, we're going to do it twice. So they have to give you 2 conditions. So these are the conditions that would be given to you. For example, you'll be given that f prime of 0 is equal to the -1, and they give you another condition that f of 0 is equal to 2. Since you have f double prime, so that they have to give you 2 conditions. Okay. Now, you have to do it in 2 steps. You integrate it once. This is f double prime. That take you to the f prime. From the acceleration, you go to the, okay, velocity. Then you integrate it again. That take you to the f of x. Okay. So that's why what we wanted to know it. Okay. So the solution is going to be integrated once. You cannot do it right away. This is f double prime. You are going to integrate it once, you go back f prime. So the f prime would be integral of a 6x squared plus 3x plus 1 and dx. Okay, that would be a step 1 from the f double prime to the f prime. Integrate. So that gives 6x cubed over 3, and that would be 3x squared over 2. And you know that integral of 1 would be just x plus the constant c. Simplify it. These 2 would cancel out. So your f prime of x is going to be what? It's a 2x cubed. You cannot simplify this one. You can add 3x squared over 2, just 3/2 of x squared plus x plus c. That's f prime. Any question? Now, Before moving on, you apply this condition to find the C. Some people, they do it at the end, which is no good. So we say, oh, I have the initial condition of f prime of 0 equal to the -1. So this means go inside, replace x by 0. So whatever you have, you let it equal to -1. 0, 0, 0, 0 plus c equal to the -1. So that gives you c equal to the -1. Okay, any question? So what do you have so far? You have f prime of x equal to the 2x cubed plus 3/2 of x squared plus x and the c. C is -1. This is f prime. So from the acceleration, we take it to the velocity now. Now you integrate it again. Once more to get to the f of x. So f of x equal to integrate 2x cubed plus 3/2 of x squared plus x minus 1 dx. You see? Integrate, easy. 2 is a number. 2. Increase the power, x to the 4th over 4. Plus 3/2 is a number. Increase the power, x cubed over 3. X, move up the power, x squared over 2. You know that integral of 1 would be -x plus again c. Anytime you integrate, you have to add the constant c. Now again, simplify first. See, these two would simplify, so your f of x is going to be equal to, that give you x to the 4th over 2. These two would simplify, so it's going to be plus x cubed over 2. And that would be x squared over 2 minus x plus the constant c. Okay, any question? So, and that gives you the general solution, but you have another condition. Look at the condition. You have f of 0 equal to 2. So operate that condition, f of 0 equal to 2. So this means go to this equation, replace the x by 0. So that gives you 0, 0, 0, 0. 0 plus c equal to 2. So c would be 2. So we substitute. So f of x would be x to the 4th over 2, x cubed over 2, x squared over 2 minus x plus 2. This would be the final answer. This is application in physics. So the acceleration is given to you. You see, this is the acceleration function, and you would like to find the position of the moving object. This is the position of the moving object. Okay. So that's just give you the hint that usually in this course, we stay with the f prime. We don't go with the f double prime, but give you an idea that, you know, what would happen in the application problem in science. Okay, so this is 4.1. And then we be ready for the, okay, taking that that quiz that I've already posted the practice quiz for you. We do it. We do the practice one tomorrow. I just do one problem from that because the notation are different, and then I do all the okay, practice one tomorrow. We are not going to give you anything new. We are right on time at the 4.1 that we should be at this time. But in your book, the direction that we are going to take is going to be different. You see, these integral are all easy because that was the power of function. But remember, when we differentiate, we just apply the chain rule most of the time. We have a power rule for the chain rule. Remember, u to the n. So I do that method first. In your book, it's something like 4.8, 4.7. But we bring it up, and we usually teach that one first so that you have all the methods. Then we go back and we look at the integral as solving the second problem in calculus, which is going to be the area problem. Okay, so our direction is going to be different from your book. So to just make sure that you are ready for it, I just give you one more, but this is from that practice one that we have, or I can make one myself, so we keep that practice one. So the notation that you use is number 3. I do this one as 4, and then I let you go. So we give you one of these problems, not f double prime. You say in a language of a differential equation for future, or in your book, sometimes they give you the problem of this form, which is the same thing. Okay, we call it differential equation, as you did it differential form the other day, remember? So this is it. You want to find the function to satisfy this condition. Okay, let me write it down. Again, find, you can say solve the differential equation. It's the same thing. Differential equation. Okay, or you can say that find a function y equal to the f of x satisfying the given conditions. So, we usually write it on a second form or just a differential equation. It's the same thing, but they give you in this form, you see, dy dx. That's it. Dy dx is going to be equal to 1 plus, okay, that's it. It's going to be 1 plus x minus x squared. I'll just give you something, just practice that idea again over x to the 5th. And the initial condition of f of 1 equal to the, let's say, -1. Or sometimes they write y of 1. Okay, in language of the differential equation, it's the same thing because we use the differential notation. So what you can do is you can change this differential notation. Remember, this is like the y prime, or you can call it f prime if you feel more comfortable. Okay, so that would be given to you in form of differential, and you can call it f prime. To handle it easily in this course, you say you have this one, f prime of x equal to 1 plus x minus x squared over x to the 5th with the initial condition of f of 1 equal to -1. This is your problem. You know how to do it, integrate it. Okay, any question? So different notations, different expressions, same thing. So now you know that f of x is integral of 1 plus x minus x squared over x to the 5th dx. You have to find this integral. We already talked about it. Move the x to the 5th to the top, or you break it as a like fractions, whichever you feel more comfortable. I would be comfortable with move it up. So it's going to be x to the -5 times 1 plus x minus x squared dx. Multiply cross, multiply go forward, x to the -5 plus x to the, you add the power -5 and 1 would be -4 minus x to the -5 plus 2 would be -3. -3 dx. Any question? Just the usual integration operations. Again, make sure you use parentheses. If you don't use parentheses, you just multiply this one. Okay, all of them. Now go ahead, integrate, power rule, x to the -5 plus 1, -4 over -4 plus x to the -4 plus 1, -3 over -3 minus x to the -3 plus 1, -2, -2. But remember the constancy. You have to take care of all those negative powers. These negatives are sign of the fraction. So your f of x is equal to, the first one is minus 1 over 4 over x to the 4th. That's the first one. Next one, minus 1 over 3x cubed. Negative, negative, positive, plus 1 over 2x squared plus the constant c. This is your general solution. But you have the initial condition. So you're not done. You have to apply the initial condition. So, oh, but I have f of 1 equal to negative 1. So you have to continue. You replace the x by 1, and you let this one to be equal to the negative 1. If you replace x by 1, that gives you negative quarter, the first one. That gives you negative 1/3, the second one. And that gives you positive 1/2. Plus the constant c, and it got to be equal to the negative 1. Any question? You have to find the c. You can move everything to the other side and just common denominator. It's a negative 1, positive quarter. Okay, positive third, minus 1/2. Find the common denominator, which is going to be 12. 12 times negative 1, negative 12. 12 divided by 4, 3, 3 times 1. 12 divided by 3, 4, positive 4. 12 divided by 2, 6, minus 6. So simplify the top. Negative 12 and negative 6 would be negative 18. 7 out. Negative 11, 12. That's it. So come back and substitute for the c, and you have it. F of x equal to negative 1 over 4x to the 4th minus 1 over 3x cubed plus 1 over 2x squared and the c minus 11, 12. So that gives you the final answer. Nice application of the indefinite integral for science. Okay, so the rate of change derivative, whatever you want to call it, is given to you and you recover it. We have a nice function for application problem, natural log and exponential one at the end. Then we come back to it again and we check it. So we are ready for your quiz. Okay, so what I do tomorrow, I will go over that practice quiz that I've already posted. It's a 6 topics, okay, optimization problems, limit at infinity, remember linearization, linear approximation, and integrations. So 6 questions. 2 is going to be from the one I covered talk about today. 1 optimization problem, 1 tangent line approximation, and the other 2 are going to be the limit at infinity. Okay, and we repeat it right away in the common weeks for your test. Okay, on test number 3, and we repeat it on the final again.